System architect plays a very critical role. When somebody asks me that question sort of on a short, if they want a short answer, I tell them I take a big complex problem and I break it into a bunch of smaller problems which can be solved individually, largely autonomously, but when each of them is solved together, come together to form a solution for the larger problem. What that requires is breaking the system into component parts. Now, modern systems can have thousands, tens of thousands of components, and each one of them has function that must be allocated to it, has data which it must maintain, and it's got to have a connectivity to some or all of those other components. So there are many, many, many ways to solve the problem, and it's not as if only one of them works, but it is uncountable the number that won't work. There's an awful lot of combinations which simply will not perform, and what I try to teach is how that partitioning can be done in a way that will produce a successful system. It becomes especially true with the big systems. You can make a lot of mistakes on small systems, and just the speed of the processors can save you. But when you're dealing with processors that are on satellites, that are in the ocean, that are wrapped around the world, the speed of light matters, all kinds of factors matter, and you simply can't get the performance unless you partition it well. So the system architect plays that role. He has to talk to the customer and help the customer tune their requirements. And then the architect must turn to the developers, a totally different language, a totally different skill set, and be able to explain to them what needs to be built. So you have that dual responsibility to communicate to both users and developers.